Okay, I'm just going to show you a demonstration of the new aircraft scatter modeling program, which you can download from my website. The link is w3sced.com/aircraftscattermodeling.exe. Capitalize aircraft scatter modeling, hit enter. The file will be downloaded. As you can see here, I've already downloaded it once today. I'm just doing it again for a demonstration. Downloaded it to my download directory. You can see it there. We'll double click on it or right click and open it to go to the installer. I'm not going to fully install here because I already did. Now Windows will not like it because it's an unknown program. So click more info, then click run anyway. And that'll bring up the installer, which will look like this except the buttons that you see are different. Where it's install there, it will say install. It says uninstall, it will say install. So you just click on that and that will start installing it, but I'm not going to do that because I already installed it. Um, Once it's installed, you can find it in several places. First place will be if you open the Windows program list. Since you've just installed it, it'll probably be right at the top on the left there, and you can click on that to run it, or you can come up to the A's in the program list. I'm trying to scroll here. It's not under W3SZ, but it's up under A for aircraft scatter modeling. So we'll scroll up there, and it'll be in a folder. So you'll have to open that folder, see aircraft scatter modeling, open the folder, and then you can just right click on it, and that will run it. Or it's on the desktop as an icon. You can see there's an icon, aircraft scatter modeling. You can either double left click on that or right click and open that to run it. It'll take several seconds to come up because it's doing a lot of stuff when it first opens. And there it is. It looks very much like aircraft scatter sharp, but the guts are quite a bit different. I can see I've got key capture turned on there and the skew lines turned on. The key capture you can turn on just by clicking the button. Same thing for the skew lines. There are other setup options under options at the top left. And you can see there you can enter the altitude for the plane, the heading, uh, the speed, meters per second, the altitudes in meters as well. And I've got a 10,000 meters, heading of 90 degrees, and a speed of 250 meters per second there. Uh, and then you can set your home and DX locations either by typing in the grids when you click the grid button, or if you click the lat buttons for each one, enter latitude and longitude. Or if you've entered latitude and longitude, you can then do Control F1 and Control F2 to place the stations. But you have to have already put an airplane on the map to do that. If you don't, you'll get an error message, as I'll show you here in a minute. I'm going to click Control F2 to do the DX station, but I haven't put a plane on the map yet. So we're going to get an error message that says the plane doesn't have, there you can see it says plane latitude not a valid number. So if you do that accidentally, then just come over and click anywhere on the map, left click, and you'll put a plane on it and actually run the data. And the plane will go along the heading that you've chosen. You obviously want to choose it so that your heading will run it across the path, and that's done it, and it's written the data to a file, but we'll deal with that in a second. Right now that we have a plane there, you can see I did Control F2, and I moved the DX station location. I'll do it again, Control F2, and we're back to about 0 degrees. We're 359.78 degrees. The path length, as you can see, is 516.86 kilometers. Okay, so now we're going to run the plane again. We'll just do left click on the map, and oh, I want to show you first the intervals of the data. You can do 1, 5, 10, 30, 60, 120, 300, or 600 seconds. It always calculates the data at 1 second intervals because if you space out the interval, the accuracy of the numerically derived derivative becomes poorer, and then your Doppler calculations are poorer. So it always uses a second for the calculations, but you can display it with the intervals as shown in the file. So now we'll go ahead, since I've explained that, and we'll right click again here to run the data. I guess we won't. I forgot what I did when I recorded the video here. Uh, I'm going to show you ordinarily when you start the program, the file will go to the directory where the program was installed, which in this case is C aircraft scatter modeling. The C drive might be different on your computer, but it likely will be aircraft scatter modeling. But you can change where the file goes by clicking the select folder button there. And in fact, I've put these in my one of my local app directories under my username, app data, local, and then W for W3SZ. Um, but I've just changed it here to put it in the C directory. And now we'll do another click. I'm going to change the heading to 45 first. We'll do a click here, so we'll cross the path at a 45-degree angle. There you go. And you can see we just created a file there in that directory. Files are named by the date and time, doppler-data.csv. Um, always writes a new file with the new time, so you don't have to worry about overwriting data. We'll open the file here so you can see what it consists of. It's got the names of the headings at the top: latitude, longitude, heading, speed, Doppler, old Doppler, Doppler rate of change, the last time interval, which always is going to be a second here, time to path in seconds, distance to path in kilometers, plane to home bearing, plane to DX station bearing, and home to DX heading. The latitude and longitude obviously are in degrees, the headings in degrees, the speeds in meters per second. Old Doppler is hertz. The Doppler rate of change is hertz per second. Time to path seconds, as I said, distance to path kilometers. The first old Doppler and Doppler rate of change are bogus because wasn't a number there. But you can see the other numbers here. We're starting out with a Doppler of about 5,300 hertz, Doppler rate of change of minus 11 hertz per second. And as we come down here, coming closer to the path, you'll see the Doppler numbers come down. Doppler rate of change actually will go up, as I think we've talked about before. And of course, the distance to path and time to path will come down. They're now around 200 seconds, as you can see, and 50 kilometers or so. We'll keep coming down. And now we're down to about, you can see there's the crossing where you go from positive to negative Doppler, and you're just at about a path crossing there, of course. So the numbers all work out nicely. Um, and again, the data starts at one side of the path, and then it goes to about the same distance the other side before it stops. So hopefully I'll close that in a second. There we go. And let's change the heading there from 45 degrees to 120. And then we'll try to cross again. We'll just do a click somewhere. And there we shot across again. And you can see we created a new CSV file down there with the new data. So that's the program. Pretty straightforward. Might be helpful in terms of getting things sorted in terms of what's happening.